Hello guys, my name is Mohammad Adolf Ferdinand. My student ID is 1911035. Today, I would like to present my presentation about reservoir sedimentation from Water Resource Management class. Table of content is first, abstract, second, introduction, third, method, fourth, result, 5, conclusion, and 6, video. First of all, I would like to present about abstract. What's the topic? Artificial water storage originated by the construction of dam is essential for the sustainable health and welfare of civilization since it supplies water for human consumption, irrigation, and energy production. Furthermore, dam reservoirs are used for recreation, navigation, and they provide safety in the downstream valley against extreme flood, event, and drought. All reservoirs are subjected to sedimentation, which, without adequate prevention and mitigation countermeasure, threaten their sustainability, as well as the evident loss of storage capacity. The adequate and safe operation of water intakes and bottom outlet belonging to the vital outlet structure can be affected by deposition of sediment in the reservoir. This vision paper first addresses the state of the art and the main scientific advance in terms of prevention and mitigation measure against sedimentation in reservoir. Then, the main research challenges which result from the assessment of what are the remaining open questions are pointed out. The emerging research methodology to study sedimentation process are also discussed. Second, introduction. A river basin conveys water, sediment, heat, chemical substance, and biological species from the hill slopes to the low hill and further downstream to lakes, seas, and ocean. The construction of impounding structure across a valley interrupts this flux, causing sediment to deposit upstream and to lag downstream, resulting in loss of volume to store water in the reservoir. Reservoir sedimentation has always been for dam owner. The outlet tunnel of the Roman Dam of Porpespina, built around 100 until 200 AD in Extremadura, Spain, are known to have been raised in the 17th century to clear layers of accumulated silt. River basin three main general processes can be distinguished. First, sediment production, second, sediment transport, and third is sediment deposition. The economic and social importance of water storage makes sedimentation in reservoir is an active and growing area of research, such as shown. Nevertheless, apart from raising the owner awareness, effort significant way to increase the expertise of researchers and engineers still need to conserve this important water. The third is method. What's the method? Work involving sediment transport, especially with fine sediment as in turbidity currents, brings similitude difficulties and scale effect regarding the intervening force. To assure similitude dimensionlessness, parameter representing the ratio of force acting in the sediment must be kept within similar range between the laboratory and nature. Since water is usually in physical modeling, the choice of sediment material used in the laboratory, which includes choosing the size and density. Regarding numerical model, there are different options, ranging from 1D to 3 model. Traditionally, 1D models have been used due to their low computational costs and reduced data requirement. However, with the presence of complex topography and/or of hydraulic structure, the use of 2D or 3D models may be required. 2D shallow water models may provide accurate prediction for the depth, average flow velocity, and water depth requiring to find topographic representation. Result: how reservoir can do. First is Chicxulub, Guatemala, which fill with sediment more rapidly than predicted. Second is Cerro Grande in El Salvador, whose lifetime was reduced by 10 times compared to the predict value. Third is Tarbela in Pakistan, where the reduction of 30% of storage was observed between 1997 and 2009. And last is this reservoir in Iran. Turbidity currents are composed by a wide range of suspended particle size. Settling of larger particle reduces the density difference and the buoyancy which maintains the flow. Thus current induced by small flood may not reach the dam. This process also causes a longitudinal reduction in the grain size of the suspended solids carried by the current and deposited along the delta and along the reservoir bed. Furthermore, the group settling velocity of the sediment in suspension depends on the concentration and particle diameter. When bypassing sediment through a dam, ecological restrictions should be taken in account. Fast current originated by flushing or sluicing operation can cause mechanical damage to vegetation and also increase the sediment risk. Suspension is sparsely vegetated and shallow area, which further reduce the light available for the subaqueous vegetation and contributes to the formation of turbidity flow. It is thus important to assess the impact of sedimentation, control erosion, and the vegetation in reservoir. Conclusion: the main relevant issues regarding reservoir sedimentation have been highlighted and discussed. Several key messages were given which address researcher, practitioner, legislator, policymaker, funding agency, and outreach and educational promoter dealing with the problem of reservoir sedimentation. The design and layout of reservoir dams have to consider reservoir sedimentation from the very planning phase. Video. Today I want to show you video about reclamation. Happy watching.
Sediment is the rocks that are transported by rivers, and it's a natural part of rivers, but it becomes a problem when that sediment is brought into reservoir environments because it can build up and cause issues to the available water in those reservoirs. It can cause flooding problems, and it can vary a lot of the intakes that we use to deliver water.
Sedimentation is affecting the project benefits for the nation's reservoirs, and we need to look at ways to better manage sediment over the future more sustainably.
There are three basic categories of ways to manage sediment in reservoirs. The first is to prevent the sediment from coming into the reservoir in the first place. That can be bank stabilization, bank protection upstream, better farming practices, anything that can be done to prevent erosion in the upstream watershed. The second method is to prevent the sediment from depositing in the reservoir. And there can be tunnels or other ways to bypass the sediment around the reservoir or to pass it through the reservoir before it deposits. And the third basic category of methods is to remove sediment that has already deposited. Things like dredging, things like opening the gates and flushing the sediment through.
The limitations generally are associated with downstream channels and their capacity. Many times flushing is limited by the ability of the downstream channel to handle a flush. And for many of the other methodologies, they can be very expensive, extremely expensive.
We need better sediment removal technology because that sedimentation is growing in a problem every year. And if we don't deal with the problem now, we're going to be passing it on to future generations. And if we pass it on to future generations, the problem is going to be more cost expensive and more difficult to figure out what to do with all that sediment.
Types of improvements we're looking for would be ability to go deeper with the dredging, going after those fine sediments closer to the dam, and also going after those coarse sediments, sands and gravels, much further at the upstream end of the reservoir, and getting that transported through without clogging or breakdowns.
In general, what we're looking for is a significant step up in efficiency. How do we do more sediment management with less resources than we currently have?
The benefits that we can get if we figure out easier and cost-efficient ways to remove reservoir sediment is that we can better manage our flood risk. We can make these reservoirs and dam facilities last far into the future.
So with the prize competition, we're hoping to focus people's attention on the issue of removing sediment from the reservoirs.
Opening this up to the public allows folks who are not practitioners and can come at the problem from a completely new perspective to bring something to the table that I or my fellow engineers may not have thought of. And that's an exciting opportunity.
Okay, thank you for watching. Don't forget like and comment. Bye bye.